Hello. So for assignment 4, for problem number 1, we have to create our own shader class called color selected 3D optimized and make use of passing a single matrix. So here I create a color selected 3D optimized shader file which has one matrix for worldview and projection, and then one for the color, a vector for the color, and then in my header file I defined only one constant buffer, and then I defined one method called send camera matrices, which sends world matrix, the world matrix, the view matrix, the projection matrix, and the color vector, and then it defines those. And here, as you can see, we just do that one pass through where we define multiply worldview and projection together. And then in our main app, we define the color and we set it to shader color optimized, and then in the draw scene we just send the camera matrices where we send all of that at once, and it does the pre-compute, and then it renders, and then we get we should get the cube. Yep. So that's problem 1. Then problem 2, we had to use number 1 from above, and we had to minimize the number of matrix multiplications, so we had to modify that. So I went back to the shader class, well, actually the header, the shader file, and I separated and created 2 constant buffers, one for the constant camera data and one for the new worldview projection matrix and the color. And then in my shader color optimized file class, I defined 2 methods, one sending the camera matrices, which takes in view and projection, and it does that, and this only does it one time because view and projection are not going to change. And then in this, when it does send world matrices, it just multiplies that the VP that I defined. I defined like a private variable called VP, and then it multiplies the VP with the world. So in essence, there's only 2 multiplications going on. So in our main app right here, we set the shader, and then in our draw scene, we're defining, since we're replicating 5 objects on the same screen, defining the world matrix. Well, first I defined the view and projection matrix, so that's one multiplication. Then here's another multiplication. And then when I send the world matrices, that's another multiplication. So what would have taken like 14 multiplications, or 15 multiplications actually, is now taking only like is a lot less, because now I'm doing instead of doing 2 multiplications per object, when I do send world matrices, I'm doing only 1. So that's that. And then when I run that, I get the 5 objects with each different position, different colors. Then for problem 3, we have to create this pyramid using this texture. So in problem 3, I created the new create unit pyramid repeating texture, and the number of verts are vastly more than the number of verts for the original create unit pyramid, because now we have to treat each face of the pyramid uniquely. So each of the 4 faces of the triangles for the pyramid, that's 3 times 4, and then the bottom 4, that's 16. So here I'm defining the vertices, and I'm also defining the UV mapping right here for the texture. So I'm defining all the faces, and then and here I defined a new case for the repeating texture, and then here I'm using this texture, and then I'm defining the sample state, and then setting to context, and then I'm defining the new model using the pyramid repeated texture, and then here I'm just rendering it and defining the world and camera view projection matrices, and then I get this. So that's the pyramid. So that's number 3. Number 4, we have to add a new pre-made model called unit box 6 face texture, which coordinates to this. And here So here I create the 6-face texture, and it's gonna have the same number of verts as the repeating texture, because obviously there's 6 faces, which 4 vertices each. So here I'm defining them, and I'm defining the UV mappings for each one, and this has all been through the math, because like the boxes were divided into 8, so it was a lot of just math, just mapping whatever the corners of the boxes were to each of the vertices. And then I defined a new method called unit case for creating the 6-face texture. And then in my main program, we're using the cube faces texture, and then we set the sample state, and we set the context, and then we're create the model using the 6-face texture. And then in our draw scene, we're rendering it, and then here we get the object front, right, back, left, bottom, and then top. So yeah, and then number 5, we have to create the shader texture class to encapsulate our work and control texture.hl, the texture shader file. So here I created, this was the definition of the shader texture class, and here I'm also creating 2 private constant buffers for the view and projection, because that's what the texture shader file had. It had 2 constant buffers for the instance data for the GAM data, and then here we're defining it just as we did before. When we do the constructor, we're setting the constant buffer, the per frame data, and then destructor, and this is for setting the context for the texture, and then here we are sending the camera matrices and sending the world matrix, and then setting to context. And then in our main program, there's a lot of code that I commented out, and then we create our shader texture, then we set to context, we define the new texture file, and then we set that the shader texture to that. We set the texture through the shader texture file, and then we define the model using the 6-face texture box again, and then here I'm drawing the scene, and as you can see there's a lot of stuff commented out, and we're just doing it into single line codes. We're sending the camera matrices and then sending the world and then rendering it, and then here we get the any second now. Yeah, here we get the 6-face texture again, but this time we're using a texture shader class that we defined, and then in terms of further work, using the 512 texture, here I defined the using the 512 texture, and then instead of using the unit box repeated, we use the unit box, which doesn't take texture UV coordinates. We just get a pink box, pink cube, instead of what we should have gotten, something like this, with the texture repeating on all 4 sides. And we see the pink cube because you are not creating as many vertices, because in our model class, or model tools class, we only have 8 verts compared to 24 for each of the faces, and you're not defining the UV. So right here we're just defining the colors. We're for the texture mapping, which defaults to 0, 0, which points to the red border on the 512 texture, and that's why we're seeing like a pinkish cube. Okay, and I think that's everything. So okay then.